All right, folks, I have 10:45 on my clock. And that means that it is about time for us to continue. Only maybe 13 check marks so far in the participants list, but I'll just quickly show how we can do the descriptive statistics for all of our columns of our data file, excluding the date. I'll do that quickly, and then I'm going to turn things over to Vuoko to continue with the second part of the lesson, and I don't want to use even a moment more of her time because she's got important things to tell you. But the way that we can do this for our 3 columns, temp, max, and min, is basically the same way that we were selecting them earlier. So we have data, and then the double square brackets here, and then temp, comma, max, comma, min. And then with that selection, we can simply add the describe function to the end of that. And when we run this, we now get our describe function for things that make more sense. We don't need to do anything with the year, month, day column. It doesn't make sense to figure out what the mean of that value is, for instance, but here we can see our selection and the descriptive statistics for that selection. So that is the end of the introduction part of our Pandas lesson, and now we'll continue with processing data with Pandas, and Vuoko is going to take the helm. So I'm going to stop sharing my screen, and hopefully if she is here and ready,
yes,
we'll see her screen in a second.
All right, thank you, Dave. And hello again, everybody. So I will continue with the second part of lesson 5. So we are then, I'll just quickly show on the web pages where to find the materials. So basically we'll now dive a bit deeper into interacting with the data, do some selections, and finally write some output to a file. So we are now starting from this processing data with Pandas that you can find from the web pages here. Here you have the links to the interactive versions, and I have my notebook open here over at CSC Notebooks under Lesson 5. It's this processing data with Pandas Jupyter Lab, and we will be using this same input data as we did in the first part. So this data with these four columns, and maybe I don't know if Dave mentioned it, but you must have figured out so far that you actually have here the year, the month, and then the day in the year MODA column, and we will be processing that information or using it during this lesson. And this is indeed an integer column when we read it in to Pandas. All right, so I hope everybody's ready to go. I'll try to monitor the chat window, but Dave can also then answer questions when we move on. So as we are now in a new Jupyter notebook file, we need to import Pandas again. You should have it typed in there ready. So we import Pandas as PD, which then saves us time typing Pandas later on when calling Pandas functions. And we will repeat reading in the file. I'll do it in a bit different way to show you a bit more options. So often it's a good idea to store the file path into a separate variable so that our code is easier to maintain afterwards. If, for example, working on different computers or changing the input file or somehow modifying your project. So we'll store the name of the file. Let's see if this, yeah, I learned this autofill. So you can start typing in Kumpula and then press the tab key so Jupyter Lab knows to autofill the file name as the file is located in the same folder as our notebook in the working directory. So now we will store the file name as a character string to the variable fp, stands for file path, and then using that, again, we'll create a new variable data, pd.read csv. So we'll pass the file name, fp, the first parameter, then we had to skip the first rows. So start reading the data at row 9 in the text file. This should now work. And let's just check. So always when reading in data with Pandas, I recommend taking the habit of printing the first 5 rows, maybe also checking the last 5 rows if there might be some empty rows or something weird in a manually edited CSV file. So always good to visually check that the data structure looks correct. You have the column headers correctly, and so on. Okay, so we are ready to go. A few more words about this file path now that we stored it separately. So as I mentioned, our Python session was able to find the file because it's located in the same root folder as our notebook. So our working directory contains both the code and then the file, so we have no problem finding the file. Sometimes you might have a different working directory where you're running Python, or then the file might be located in a different place. So in those cases, you might need to define the absolute path to the file. So in our case, if we would define the full path, which in these cloud computing environments starts from home, work, notebooks, and so on, so the full thing. So we could also then read in the file like that. On a Windows computer, then file paths would sound something like C drive dash local data dash username dash data codes, whatever, and then file name. And we will later on learn efficient ways of how to manage these file paths. But I want to raise this point to remind you to be aware of where your data files and your script files, notebook files are located, because then often when reading in files, problems might be related to Python not just finding the file. All right. So if you want, later on you can try to run this code block to see what happens. And then an additional note is that, well, especially on Windows computers, if you would have like / notebooks something, so then the file path might break, as we have. I'll just demonstrate it quickly. Let's see, fp equals, I would have C, improvised example. I would have a file path like this. Then what actually happens is, if I print it out, so you get, instead of the full file path, you actually, Python interprets this escape character \n as a new line, which we have seen before, which then breaks your file path. So in these cases, or in other words, always when defining full file paths, it's good to pass them as so-called raw strings. So you put this little R prefix. So if I now run this again, I would have a clean file path to this imaginary file. In this cloud computing environment, it shouldn't cause any problems, but just for kind of further notice, you might run into troubles with things like these. So good practice then to put this little R in front of the file path if having the full full path in there. Okay. Yep. All right. So let's move on with some basic calculations with our data frame. So our data is now stored in this Pandas data frame called data. And if we want to create new columns, for example, do this for each row, do a calculation, we can create the output column. So thinking about that, we would here now, for example, want to calculate the difference between maximum and minimum temperatures to get the range as a simple example. So we can create a slot for the results of our calculation. So create a new column and populate it with some value like this. So this syntax will create a new column and then for each row assign the given value. And let's see what our data looks like. Just print the first rows. So using these square brackets, we have now created the new column. It has some floating point values in there, and we can also verify the data type of the last column, for example, like this. So it indeed is now a floating point value with 64-bit precision. In Pandas, it doesn't really matter if you're then updating columns. You could update the column with, for example, character strings. So Pandas will allow you to then change the data type when working with the data. All right, so now we have this new column with some slots for the calculation. And as a simple example of a calculation between Pandas data frame columns, we can do something like this. So we'll take the maximum value, reduce the minimum value, and store that into our new column. Okay. So column name, in a way, we are doing Pandas series minus another Pandas series is then assigned as a value to this column that exists in the data frame called data. Again, after making some changes, I check what happened. So as I said, we have now some new values in here. They seem logical, and if there has been some missing data, then the output is also not a number or this NaN value. Okay, here we did so that we first created this empty column and then we populated it with values. We could have also skipped the first step and just run this line directly. So you can kind of create the new column on the fly when making calculations. But in some instances, you might first want to create the slot for your outputs, and then maybe then afterwards we will be doing calculations row by row. So then it's handy to have the data structure in place first and then update the values. Okay, so we can also do other types of algebra or basic math with Pandas data frames. So we all know now how to convert these Fahrenheit temperatures, which are the input values in our input data frame as it comes from NOAA, the US climate database. So we can convert those to Celsius values in Pandas. So for that, let's make a slot for the results. So we'll create a new column, temp Celsius here, just a side note, it doesn't matter if you're using single quotes or these double quotes. I think my keyboard habit often tends to put these double quotes. And then equals, oops, that was already there, some calculation. I'm now checking the syntax from my monitor. I don't remember it by heart, but you can type along as I do. So the conversion formula had two parts. So the first part is Fahrenheit temperature minus 32, and then divided by 9/5. So we can do this in the similar logic as in here. So just type in the values, and Pandas will repeat the calculation for each row. So data temp, which is the Fahrenheit temperatures, minus 32 divided by 9/5. Dave can correct me if that went wrong, but I think my notes are correct. Okay. Running that will store the output to this new column. Maybe I put these spaces in here so it's easier to read. And then we can again check data.head, the output. So now these, if we're talking about Kumpula in June, so the first month of summer, average temperature of the day 18 degrees. It has been rather warm. Then you see more these realistic Finnish summer temperatures, 10 degrees at average on June the 5th. Sounds reasonable. If you want to see more data but not the whole data frame, you can then pass a parameter to the head function. So it's been started off nicely. When schools ended, it was very nice, and then it was rather cold. So I think this went all right. Okay. And in case I'm going too fast or too slow, please let me know. But now we stop a bit and give you some time to think on your own. So continuing with the idea of temperature calculations, we can also then add more information and create a new column for temperatures in Kelvin that we already discussed last week. And as you might remember, 0 kelvins equals to minus 273.15 degrees Celsius. So based on this information, you should be able to create a new column temp Kelvin to our data frame data and do the calculation based on this column we just created. So take this idea, but change the conversion formula. And once you're done, I would ask you to again put the little green check mark so then we can check the solution together. Okay, I think we're close to the number of green check marks we've had before, so I'll go ahead and show the solution. And Dave, again, if I'm doing some stupid mistakes, please stop me. So we are still dealing with our data frame. I'll just check what we have at this point. So we have so far created 2 new columns, and I want to create yet another one called temp Kelvin that would then get values based on data temp Celsius plus 273.15. There we go. And we can again check what happened. Yes, so these Kelvin values are not so logical to me, but let's hope our conversion formula was right. So you get the point. We can do calculations, add static values, plus and minus existing columns. If you want to do divisions between columns, then it gets might get a bit more complicated, but we might get back to that. All right, so that's it for basic calculations that might come in handy in different occasions. Let's move on to selecting rows and columns. So you already saw how to select, subset the data based on columns, but we'll now learn a bit more advanced tools for doing the same thing, and also then kind of slicing the data based on rows. So this will be useful when doing selections, subsetting the data, applying some functions only on specific parts of the data, but also hopefully will help you further understand the data structures we're dealing with. So the Pandas data frames, Pandas series, the indices and axis labels, row labels and column labels. Okay, so let's start with kind of a very simple example. We still have this data. I'll just again print this data.head to remind you that we have these column labels at the top, and then these row labels that are at the same time showing the kind of index of each row. So we have row 0, 1, 2, 3, 4, and so on. And actually we also have column 0, 1, 2, 3, 4 index value starting from 0, as with Pandas lists before. So if we would want to select, well, we get the first 5 rows also with this head function, but another way of achieving this is taking a slice using the indices. So we want to select rows starting from row 0, and then we want 0, 1, 2, 3, 4 indices, so the first 5 rows. And as with indices with the range function, the last value is not included. So if we put the range of from 0 to 5 in the brackets, we can kind of cut out the first 5 rows from the data frame. You rarely need to do this, but this maybe helps you understand how the indices are in there. So we could also then, for example, skip the first row like this. So now we only have 1, 2, 3, 4, and so on. Okay. All right. So these were integer indices that we used in here. But then we will introduce another, maybe a bit more powerful way of accessing data in Pandas. So the lock accessor, I guess it's called. So if we want to select rows and also select columns, we can do something like this. So we do data dot lock, and then these brackets. Again, we specify the rows. And let's see what happens when we do this, and then comma, and we can pass a list of columns. Same way as we selected only specific columns, but with this lock accessor, we can combine that with a subset of the rows as well. So temp, and what else do we have? For example, temp Celsius, if we want to compare those two values, or maybe print an output with Fahrenheit and Celsius next to each other. All right, but now pay attention here. You see that we get 6 rows, 0, 1, 2, 3, 4, 5, instead of first 5 rows here. So what's going on? So here actually this lock, when selecting the rows, it takes the labels. So these actual labels 0, 1, 2, 3, 4, 5. And when using this one, then the ladder value is included. So this is a bit confusing, I know, but it is more clear if we would have as row labels, for example, dates, or it could be some other categorical value or whatever. So these row labels don't have to be numbers ranging from 0 to something. So I'm just pointing this out in here so that you pay attention later on when making selections, that actually when specifying the rule for the rows in here, the kind of the whole range in a way is included if doing it like this. All right. Okay. Next. So yeah, I probably skipped one step, but that doesn't matter. This was actually supposed to be down here. Sorry for that. Maybe to go back one step, if we wanted to then select only one column from those first rows, we can then just pass temp. So in a way, the same thing as we select one column, so one series, we then use this lock accessor to add the rule for the rows. And same thing in here, as we are using the lock accessor, we use the axis labels and we get 6 rows instead of 5 rows when using the indices with this slicing approach. Okay. Yep. Okay. Sorry for jumping up and down. I hope you got something out of that. We can check that you understood in this next check your understanding block. So I'll clear the check marks and explain. So here, based on this introduction that I just gave, using the lock accessor, I would ask you to find the mean temperatures. So you remember this dot mean function that Dave showed for the last 7 days of June. And you should first select part of the data frame using the rows and columns, and then apply the mean function to that selection. All right. So spend a moment thinking about that, and I'll then show the solution in a bit. Okay, in the interest of time, I'll start going through the solution. And now that I was looking at the instructions, I know that it was maybe a bit confusing. Is it the index we're using or the row label? But let's see how it can be done using lock. So basically, we're making this same selection that's visible using the tail, showing the last 7 days, so June the 30th and 7 days before that. It was rather warm. So we have data.lock. First, we specify the rows. And now, again, when using lock, we use the row labels. So we can just cheat from here. The first one is 23, 4, 5, 6, 7, 8, 9. So that's the seven last days based on the row labels. So we can specify it like that. 29 will be included. And then we wanted column temp Celsius, right? So that will give us the selection as a Pandas series. And then we can apply to that series that we get as output from the selection mean, which is something around 18 degrees, which looks correct. Okay. So some of you managed to do this. I hope the rest of you are following, and you'll get to practice the lock more in the exercises. Okay, let's move on. There's a couple of more examples, these kind of generic examples with lock. I'll just show them quickly. So you can also use lock for selecting one row. You can store it into a variable data.lock 4. So again, this will access one row. which a row is a Pandas series. And when we have a Pandas series, it's a bit, as Dave mentioned, so it's kind of like a list, but more smart. So we can use these data frame-like things when accessing values from a Pandas series. Of course, only one value at a time, because, or maybe we can also access several values. Anyway, so we can access one value from the series using its label. So here are the labels, there are the values. All right, finally, we can also access one cell or one point at a row and a specific column. We can do that using lock, but then also we could do data.at specific row, specific column. So we get the value if we print out data.head. So we get the value at row 0, column temp is precisely this one. And you might want to use this at accessor when, for example, updating a specific value. More often that would be maybe with categorical data or something else. I think this is a bit faster than lock or something when accessing, if you need to access just a single value. Okay, so now we have learned to kind of subset the data based on rows, based on columns. As outputs of those selections, we get either Pandas data frames or data series, and then those objects we can then again apply these functions or take statistics out of or continue processing. So we are kind of modifying the input data according to our needs. So somebody asked the question during the last check your understanding that could we select with kind of negative index. So that is possible. I won't go through this now in detail. I think at least myself, I rarely use the iLock accessor. So this iLock instead of lock then uses these 0, 1, 2, 3, 4, 5 indices. So using the iLock, you can then instead of using the labels, use the row and column indices for accessing the data. But I'll skip this for now in order to have more time to go through filtering data and updating data. So here we will now combine conditional statements, so making decisions when selecting data. So of course, when doing data analysis, we often want to ask questions from the data, and we might want to select data if a certain condition is fulfilled. For example, if temperature is greater than something, then for those rows, we want to continue the processing. Okay, so let's see how we can bring in conditional statements when working with Pandas data frames and Pandas series. You remember these Boolean true false values, and now we will kind of have arrays or series of true and false values depending on the value on each row. Okay, so let's build this in two pieces. We first need to make a condition. So we have our data. Let's take the Celsius temperatures. That would be greater than 15. This is quite logical, the syntax in terms of how we would spell it out in plain English. So if we run something like this, you see that we get yet another Pandas series. So something with labels or indices, and then for each row, in a sense, we get true or false depending on if this condition was true or false on that specific row. Makes sense? I could add here again data.head, and if we just check temp Celsius was greater than 15 on the 3 first rows, but not on the 4th one, so then it's true, true, false, 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 false. So it was then quite cold in the start of June. Okay, so I hope this makes sense. But then how to select rows based on this condition? So we again take this lock accessor. So we do data.lock brackets, but instead of giving the labels for the rows we want to select, we actually pass this true or false series. So we put the whole condition in there, data temp Celsius greater than 15. So you can imagine that we pass this series inside the lock. So what this does is that then Pandas takes in a way you have the data frame there. Pandas, I would say that it overlays the series with these true and false results, and then kind of masks out or those that are false and selects those rows where the condition was true. So if you run that, I'll add a bit of spaces in there so it's easier to read. You see that we have now lost some data, and at least the temp Celsius column seems to be correct. We can store this into a new variable form, temps, like this. So we can continue with this data frame then afterwards. Okay. So condition based on which we do select the rows where this condition was true. Okay. I'll do so that you can also copy this line in here. We will extend this condition with another condition. So here we are still selecting the rows, so the days where temperature was greater than 15. And then we would want to add another condition based on the date, so from late June. So how can we do that? So we can make a condition, even though these date values are stored as integers, we can still do comparisons among them because the previous day is always a smaller number than the following day. So we can then add a condition in here. Let's copy this one from here. Like that. I suggest you surround it with brackets. I think the syntax requires it so. So now we have two conditions. Wait for it. Too fast. Sorry. Okay, maybe I'll take an additional column to show you what is our actual rule. So we have this, yes, and I have a syntax error. There we go. Okay, so we make a new rule that is data column year moda equal or greater to 15th of June. This would again give us true and false values, and it's true in late June. We can combine these two conditions. If we take now this condition that we had previously, I surround both the conditions with brackets to make it easier to read and for Python to read it in the correct order. And then we had these and or operations 2 weeks ago. In this case, when we are doing this kind of checking for each row, we have to use this bitwise operator and. So logically, this will now then combine these two conditions and check for each row where these are true. So logically, none of the first rows are true. Then in the latter June, we have some false values when it wasn't warm enough, but otherwise then the both conditions are true. Okay? And this whole thing might be difficult to follow when I'm typing, but you can check the syntax then from the course pages. Make sure that it's correct. Will then give us those rows in late June that are greater than 15 Celsius degrees. Okay, and now if you have some questions, I'm happy to answer. Otherwise, again, you will basically do this exact same thing in the exercises, so don't worry if this now was a bit fast. Okay, I think we will go a bit over time, but I think there's some important things to still go through that I want to cover. I'll show this, maybe this next step still. So we have this warm temps, which looks nice. But sometimes if we have made some modifications, we have now selected our focus days. We want to focus our further analysis on warm days in late June. So it's often a good idea to reset the index. And you can do that with this reset index function. Let's see what this would output. Now you can see if I just run it like this, it will store the old index as a new column. You might want to do that, but if you just want to update the index, you can also then tell Python to drop the old index. So in this way, we can then update the index of the selection starting from 0, ranging up to the last value. Notice that this doesn't get stored anywhere, so we need to either replace the old variable with this new one with the resetted index, or then you might want to apply the function in place. I think we'll discuss that later. Okay. We had the next check your understanding block in here. In the interest of time, I will show it and talk you through it. And I hope then if you have any questions, you then ask later and go to the exercise sessions to break it down into pieces if it's difficult to grasp. So here the task would have been to find the mean temperatures in Celsius for the last 7 days of June again, but this time selecting the rows based on a condition. So this would be the more logical way to do this selection. So based on the date values. So let's start with the condition. Data year moda is greater than see, I have there 24th. I think that holds. So the 24th of June, and then the last days. This is our condition, right? Then we want to put that one inside the lock. So that is now our condition using data.lock. Okay. So data.lock with the condition of based on the dates selects now the last 7 days, right? And then from that output, we take the mean value. now we get all the mean values. We only wanted the Celsius value. So we can add that in by applying the log selection only to the given column. All right. So you see here, it starts to get a bit more complicated. You need to understand the conditional values, applying the function to the object, selecting a column using the log. So there's many new things, but as mentioned, we will practice these things during the rest 3 weeks. All right. Let's still see, what should I go through? At least writing data to a file. You can read this note about the difference between taking kind of a true copy of a file instead of taking a view of the file. You might sometimes get warnings related to applying or changing values of a slice of a copy. We can discuss that later. Dealing with missing data is an important topic, so I'll show that quickly. And that can be done in Pandas using the drop-NA function. I'll show it quickly from the documentation. So as Dave already showed, the Pandas website, often you don't remember by heart what all these functions do. So do go to the Pandas documentation to see what's going on. So in all simplicity, this data frame.drop-NA removes missing values. And as discussed, we have these missing values now in the data frame as NaN, and we have those in the min and max columns, I think. So we can take our warm temps, for example, check how it looks like. Maybe we have some missing values in there. No, let's take the original data because that at least has some, I think it should have, yes. We have some missing values here in these columns. So if we take this drop-NA function, like this, we drop all the rows with missing values. You might want to be careful when doing this. Often it's a good idea to control which column, from which column Pandas checks for the missing values. So that we can do using subset equals to list of columns. So then min. So in this case, Pandas has now dropped no data values, rows with no data values in the min column, but retained rows with missing values elsewhere. So it's good to be in charge of what's happening and then do the selection in here. All right. What more? I guess if we want to actually store this output so it now doesn't get stored anywhere. Sorry for jumping around, but I'll change this as warm temps as it is in the instructions. Warm temps. Make at least sure that we don't have any missing values in there. So in this way, it actually gets stored in there. Another way is to apply the function in place equals true, which would then update the values and return none. So one of the common problems is that with Pandas is that you do something, you print out the solution to the screen, but you don't actually save the output anywhere. But you'll get to deal with missing values also in the exercises. Another maybe not such a good idea is to fill in missing values. I'll show this still because, for example, when dealing with GIS data, you might need to have some value in place of no data instead of none or NaN or something kind of more cryptic. So if we would do, I'll take this, data.fill NA -9999. So Pandas goes and checks the NaN cells and fills those values with this -999. But here the danger is that if you would then take averages, sum the data, do any calculations, all of that would be then wrong. So then often you might want to do this before saving data to a file and importing maybe to a GIS software where you then specify that -999 is the no data value. Okay, so prefer not to do this unless it's really needed. But often you might then have to drop NA values for some further calculations. Okay, I'm running out of time, but as promised, I will do some overtime. If you're hurry someplace else, you can then check the video recording afterwards, because we should still cover at least saving data to a file. Data type conversions are quite simple. I think I'll leave these. You can check them from the web pages. Can show the syntax quickly in here. So in Pandas, we might also have to do data type conversions. For example, from floating point to integer, and we do that using the astype function, pass the wanted data type. But here, if you just convert floating point values to integer, what Python does is it truncates the value. So it just drops everything after the decimal point. What you want to do in order not to mess up your data is to first round the values using the round function. So I have column.round 0 to 0 decimals, and then convert that rounded value to integers. So this is an important point. The syntax is not that difficult, but just pay attention when converting from floating point to integer. You might lose some data, and then, for example, further averaging might go wrong. Unique values, one of the many possibilities you can do in Pandas to get kind of compressed information out of some columns. So often, of course, for example, in my work, I've been working with social media data. So if I have multiple rows of data, but then, for example, from 5 respondents or 5 users, then with this unique function, I can check how many unique values there are in one column. In this weather data example, we can check how many days or what are the unique temperature values, for example, in June. So that might come in handy later. You can sort data using this data.sort. There you need to specify the column using this by parameter. So here we have sorted the data by temperature, and you can see that it's ascending order. So the smallest value is first, and then the greatest value is the last. If you want the reverse order, so kind of descending order, then you need to specify this ascending parameter equals to false. All right, so things like this, sorting the data, resetting the index. Maybe after sorting the data, you might want to then reset the index again. You often want to do before saving the data to a file. If you want to give a nice output then to your colleague or publish online or whatever. And also this is a quick way to check what's the maximum value, for example, if you sort the values. And things like these, if you don't remember by heart, you can often Google Pandas sort values descending, and you'll find the documentation online, or you'll actually probably find our course web pages. Okay, but if Dave agrees, I would still want to show you how to save data to a file. So I think we'll go will stop at noon sharp latest. I hope you have time to stick around, because now we have read-in data, we have interacted with the data, done some data exploration, some selections based on conditions, sorting data, all these sorts of things. You could add to the processing phase. And finally, we want to write the data to a file. So I'll go back to my notebook, scroll over these parts that I skipped. So when writing outputs, you need, of course, some place to write the output. In this case, we need a file name or path to the output file that we want to save. So in the same way as reading in the file, we'll create a new variable, output fp equals to something. So we are saving Kumpula temps from June 2016 to CSV. We haven't done any massive and great data analysis yet, but at least some data processing, and maybe clean the file, remove these first 8 rows and so on for further analysis. Okay, so we store the character string file name to the file path, and without any further folder structure, the file gets stored to our working directory, which is in this case the lesson 5 folder. All right. We use this pd.read_csv function when reading in the file. When writing outputs, we call the data frame, so data.toCSV function for writing outputs based on this data frame. We pass the file path, and we can specify the delimiter. I think if you would be working on a Windows computer with different local settings, you would get the delimiter that is based on your settings. So if you want to make sure that the separator is comma, you should specify it in here. Okay, if that runs without errors, you can go to this folder file browser, and you should have a new file in here that you can double click open, and you should see the data. I think it looks fine. It has also printed the index as its own column. We could also get rid of that, but otherwise we have a nice output in there. We can do more. So kind of in order to nicify the text file that we are printing. So let's create a new output file path. 15, let's hope our... So you see I'm making this kind of stupidly long file name, but it's better now that we don't have, of course, we have this Jupyter notebook as documentation of what we have done, but always, I think it's a good habit to have informative file names at least to start with, unless you have otherwise documented what actually is the point of some output files and the processing steps behind them. So we have this warm temps data frame in memory. You remember we selected the values greater than 15 Celsius degrees from after June the 15th. So we can do to CSV using this output fp2 again, comma. As the delimiter, I mentioned this index. we saw in here, and it's actually a bit troublesome because it doesn't by default come with a column header to the file. So often, unless you need it, you might want to do index equals false. So that will drop the index from being saved to the file. And then furthermore, in this first output file, we had these like floating point decimals, which don't really contain any additional information after the first maybe 1 or 2 decimal points. So we can also make that nicer in the text file output. So there is this float format parameter, which then helps us to drop some of the decimals in there. Here the syntax, it looks a bit cryptic, but I'll explain it. So %.1f. So in short, what this does is that it takes in the numerical values, so the floating point values it finds in your data frame, kind of puts it in here, and then it checks the number in here. So we have 1. So 0.1, we want to keep 1 decimal place rounded up to that when formatting the numbers for the output. That ran without problems. We have now this second, whatever you put here as the file name will be the file name in the computer. And if you open that, we have dropped the index, and actually these now these temperature columns are quite easy to read in this CSV file. Okay. So that's the basic end point of this input processing output workflow that we will be using for processing data. All right, sorry for going a bit fast. It was anticipated that we have a bit too much content in terms of the time we have for the lesson. But as mentioned, there's even more things you can do with Pandas. And the most important thing to do is to think about what you want to do, formulate that as a question, and then you can search from Pandas documentation, search the course web pages, search from a search engine on help of the specific syntax on how to do things. Okay, do you have some questions related to saving files at this moment? I see none. Maybe, is it okay, Dave, if I proceed to explaining the exercise while I'm sharing the screen? I could go ahead and do that, and then Dave can have a final word if he likes. So exercise 5 is available. Again, you should start it by clicking on this link. So via GitHub Classroom, you'll get your personal repository. And maybe good news for some of you, as we mentioned in the start, so pair programming will be optional starting from this week. As the exercises start to get a bit longer, we know that all of you learn in your own pace. Those of who have enjoyed pair programming, please continue as you did. You can have driver, navigator, work in the real pair programming style. Also, if you just want to have this assigned chatting buddy, as some of you said, but still submit your own exercises, that's fine. We would ask you to inform the course assistant who is grading your assignments if you decide to start submitting your own exercises. So we give some responsibility to you to let us know how you decide to proceed. So I hope this change now allows you to proceed on your own pace, but also I'm really positively even surprised on how well this pair programming has been received by you, and I'm happy if it helps you to learn during this remote situation. Okay, There are some hints on the exercise hints pages, and again, don't hesitate to ask on Slack if there's anything weird. I'll show this public version of the exercise on GitHub. So surprise, surprise, Pandas is the topic or the main tool in this lesson. Deadline is again next week's Wednesday morning. And you should start by cloning your personal repository to the cloud computer or your own computer. We will be working with weather data. Again, it's a bit different file. So I guess this is the original or almost the original format in which you get the data from when downloading the data from NOAA portal. Dave can correct me if I'm wrong. So there are a bit more columns than in our lesson data set. You can see that there's some weird characters. So these are actually the node data values. So you can see, find from the repository, there is this text file that contains the metadata and description for all of these columns. So you might want to check that. So there's a lot of information we won't need, but then again, there's certain columns we want to analyze. And then the actual data is again a CSV file. Maybe let's see. This was a good idea. It has quite a few columns. So these are weather stations or observations per weather station. So there are some weather station IDs, again, some year and date values, and then these different observations such as temperature in Fahrenheit that we will be analyzing. So spend some time familiarizing yourself with the data. In terms of the problems, we have three problems. Oh yeah, so the relevant columns are listed in here. So problems, again, they repeat what we did today during the lesson: basic statistics, subsetting the data, doing a bit further analysis and saving output files. And then the fourth problem is optional. In fact, we will cover the topic of the fourth problem next week. So it's kind of a good idea for you to read Pandas documentation on your own and see if you can grasp the idea of data aggregation on your own. So in our input data, we have, I think it's hourly or almost hourly observations. And in the problem 4, you would then aggregate those as daily observations. Maybe we can have a quick look inside. So the instructions are again quite clear. As a reminder, we will have the very final exercise with less clear, more applied instructions. First problem is basically just recapping basic Pandas functionalities. In the second one, you will do some selections, so you will get to use these conditional statements and the lock indexer for sure. You see the familiar conversion function in there. So we will actually extract data from some stations in different parts of Finland and analyze data from those. And I think in this then final problem, you will actually then print out some data files for each station. So you'll get to practice all these different parts: reading in data, exploring the data, doing a bit of calculations, selections, writing outputs in exercise 3. So noon sharp. Dave, do you have something to add? Oh.
No, I don't know that I have anything specific to add. I guess one thing I did notice is that there were about 9 more people that added their feedback to the course feedback form. So just one more reminder for the midterm feedback, if you haven't done it yet, that you can please do that by end of the week, I think is what we're thinking for how long that midterm feedback is available. And otherwise, this exercise, I think, is a bit of a leap in terms of the programming challenges that exist. So just be sure that you give yourself a little bit of maybe extra time to ensure you don't get stuck in sort of feeling panicked at the end if you're running out of time. If there are big problems that come up, we're always willing to be a little bit flexible about the exercise due dates, but I think it's just good that you take a look early on with the exercise. And if you haven't been going to the online sessions on Thursday or Friday, you could also think maybe it's worthwhile to go in this week and just check it out so you can get some help if you do get stuck. But otherwise, I think I don't have anything else to add. Next week, we continue on with more data analysis using Pandas. And I think we'll also talk a little bit about some debugging issues and how to handle and understand error messages that come in Python. And then we only have one more week to go after that, where we get into data visualization. And that's going to be it for Geo-Python 2020. So I think that's it from me. Good luck. And we will see you in the exercise sessions.
Yep. Yes. So please be active in Slack, in Zoom, with your pair or alone. So these will require a bit more thinking in the exercises this week. All right. Good luck.